Storage for over 2 years and is responsible for the Northeast SE team. Ryan has an extensive background in storage and virtualization and has co-authored 2 books on VMware with O'Reilly Publications. Nimble Storage thinks enterprises shouldn't compromise on performance, capacity, ease of use, or price. So they developed the first storage architecture designed from the ground up to seamlessly integrate SSDs with high-capacity disks, all to give you unparalleled performance and capacity efficiency, easier backups and DR, and stress-free operations. We're pleased to have Ryan join us this morning, so without further ado, I'd like to turn things over and let him get it started. Ryan, whenever you're ready.
Thanks, Jake. Good morning, everybody. So today we're going to talk about flash in the data center, and specifically around how Nimble Storage can help in the data center. So just a little bit of background on the company. So we were founded in 2008. We had a successful IPO in December of 2013. We currently have headquarters in San Jose, and then also on the East Coast in North Carolina, which is referred to as Research Triangle Park down by Raleigh-Durham. We also have operations in the U.S., Canada, Europe, and the Pacific Rim as well. So when we built Nimble Storage, we wanted to create this foundation, and we kind of picked these 5 things that we wanted to accomplish when we came up with the product. We wanted to build the world's most efficient storage system, something new, something fresh, something that hasn't been done in the past. We wanted to make it very simple and easy to use. We didn't want storage administrators spending hours creating LUNs and volumes and managing things and moving data around. So we wanted to create something very simple. We wanted to give the customers the most flexibility from a scaling perspective. So we didn't want to pigeonhole a customer and tell them they had to buy a new platform. We wanted to give them the options to scale, and we'll talk about those today as well. We also wanted to offer our customers data protection. We want to simplify their snapshots. We want to simplify the replication and the DR story that goes along with that, and that's something that we'll talk about today as well. And then lastly, we want to provide the best support and analytics in the industry. And we've done a really good job around our auto support system and our analytics portal called InfoSight, and we'll touch base on those towards the end of the presentation as well. And at a given time, please go ahead and use the chat if you have any questions, and we'll address those at the end. So jumping right to it, what have we accomplished since becoming a company? We are the fastest growing storage company in history. So if you look back at our competitors and where they were in their company lifespan and where we are today, we are the fastest growing storage company in history. Again, the successful IPO in December of 2013. We're on the Gartner Magic Quadrant as well. As a visionary, we have over 8,000 systems deployed in the field and over 3,000 customers, and we have about 900 employees worldwide today. Again, we provided and announced a really advanced monitoring system called InfoSight that our current customers have access to that doesn't cost any additional fees, and they can see when their environment is going to run out of capacity or performance, and they can see a whole lot of other analytic data to help them in their environment. We have strong industry partnerships with VMware, Cisco, Microsoft, Citrix, Commvault. We also have Cisco reference architectures around their UCS product line called SmartStacks, and it's basically a predefined and configured pod basically around VMware, Hyper-V, Oracle, SQL, and it's a nimble array with specific UCS hardware, and we refer to that as a SmartStack. You can also check out the stuff on our website at nimblestorage.com at any given time. So I want to talk about the new products. We've launched quite a few new products here in 2014, and I just want to recap and talk about those really quick. We launched the CS700 series earlier this year. This is based on the Intel Ivy Bridge processors. This system will do around 125,000 IOPS with just 12 spinning disks and 4 SSD drives. Investment protection, there's no forklift upgrades with this. And we have flexible connectivity options, so we can do 1 gig iSCSI, 10 gig iSCSI, 10 base T iSCSI, and we can also do fiber channel as of today. And we also use RAID 6 as our RAID mechanism on all of our storage devices, and we have a triple parity RAID protection on those as well. We launched the all-flash shelf as well. This allows us to add more cache into the system. So we can attach this to any of our products today, 400 series and up, and allows us to get 25 terabytes of cache in this 3U16 dry bay chassis. So it's ideal for large VDIs deployments, large database deployments, VMware environments, those types of things. We can mix and match SSDs in this environment using different SSD sizes to really kind of customize what we need as our customers grow from there. And again, this is non-disruptive. We can add these to an existing system without any downtime. In addition to the all-flash shelf and the CS700, we launched a few new products here, the CS215, the CS300, and the CS500. And what you'll see here is that these are also based on the Sandy Bridge architecture, and you can see that the IOP workloads scale as we go up in the product line here. And essentially what this is each unit has more memory and more CPU, and that's really how we get the acceleration of the performance out of our system, and we'll talk about that in a little bit as well. Again, investment protection, no forklift upgrades here. We can seamlessly migrate from a 300 series to a 500 series or a 500 series to a 700 series just by doing a controller upgrade, and that's non-impactful to the environment when that upgrade takes place. Again, flexible connectivity options. We can do 10 gig, 10 base T, 1 gig iSCSI, and we can also do fiber channel as well. As of this morning, we launched fiber channel. So very excited here at Nimble. Primarily, in the last couple of years, we've been only iSCSI based. So today marks a huge day in the company's history that we're actually launching fiber channel. We've been successfully deploying these and testing these out in the field for quite some time, and very excited that this has become GA. In addition to the fiber channel, we're also launching new expansion shelves that have 4 terabyte drives, and we can also utilize 1.6 terabyte SSD drives now, allowing us to scale 25 terabytes of cache in that all-flash shelf. With that, we also released the availability to have 6 expansion shelves attached to one of our controllers. So this gives us a huge increase in how much storage capacity you can actually have per storage stack today. The effective capacity up to 600 terabytes per array. So it's pretty powerful from that perspective. If we look at building these out and what this would look like in a scale-out 4-node cluster, you're looking at about 500,000 IOPS of performance, 128 terabytes of flash, and about 2 petabytes of capacity across the 4-node Nimble cluster. So let's talk about the technology here a little bit. So if we take a look at the storage industry as a whole, back in the 80s, we had direct attached storage. HP and IBM were primarily the 2 big players back then. In the 90s, we kind of moved into this network storage concept, and EMC and NetApp became pretty popular. They captured a huge market share there. And those technologies have really kind of stayed with the industry throughout the years. And we felt that there was an opportunity here to do something a little bit different, utilizing flash, Intel CPUs, and the cloud. And it gave us an opportunity to look at what the storage industry has done in the last 20 years and how we can look forward 20 years developing a new technology that will scale based on technologies that do change. So if we take a look here. So flash and disk are complementary to each other. So if we take a look at what a spinning SATA drive or SAS drive is good at, and we take a look at what flash is good at, flash is good for random I/O, not typically good for sequential I/O, and the write endurance is poor. Typically, as you're writing into SSD drives, they only have so many cycles that we can actually write into those. On the other hand, a spinning disk is really good at sequential I/O, has a large amount of capacity, and the write endurance is proven, right? So disk technology really hasn't changed that much in 20 years from a spinning disk perspective. We have 7,200 RPM drives, 10,000 RPM drives, 15,000 RPM drives, and what has really changed is just the capacity. The speed has stayed the same. But flash is fast. Flash is durable when used in the right context, and also is getting more dense in capacity. You know, I talked a little bit about the 1.6 terabyte drives that are available today on our platform. You know, that's a huge jump from the previous generation of product where we were only using 800 gig SSD. So SSD drives are starting to get dense, allowing us to pack more flash into these systems. So our core design principles: efficiency, leverage flash and disk for what they're really good at, and be flexible, adapt to workloads as the customer workloads change. So we want to be able to fluctuate our system intelligently as the customer's environment changes. So how do we do that? CASL is our file system. It's a flash-optimized file system. In part, CASL makes up a few different things here. We have efficiency. So we utilize CPU and memory for writes. We utilize SSDs for cache reads. And we also leverage compression in our technology, and I'll talk a little bit about that here as well. Integrated protection, so snapshots, backup, recovery, replication, all integrated and built into the product, no additional cost there. Over 50% of our customers actually buy in pairs and replicate between two sites. Scale to fit, non-disruptive, flexible. We can scale very massively. I referenced the slide earlier. You know, 500,000 IOPS of performance, 128 terabytes of cache, and over 2 petabytes of capacity is a very large environment. So we can scale from a very small environment to a very large environment. And then proactive wellness. With our auto supports and InfoSight analytics system, we can provide a lot of first-level support that's automated, and we'll talk a little bit about that later on in the presentation. So flash requires a ground-up design. So I'm going to go and just build this slide out here real quick and talk to all the pieces. So when you fundamentally build a file system that sits on top of a storage array, every storage manufacturer has this file system. We call ours CASL. You have to take a lot of different things into consideration when you build that file system. So, you know, you have your foundation, which is the file system software, the operating system, and on top of that, you want to build in your data management, compression, snapshots, thin provisioning, replication, and all the other pieces. And then on top of that, you have your application integration, so Microsoft applications or Oracle or SQL, VMware. Those types of applications have to integrate as well. So you have to really design this system from the front up, forward thinking, okay, I need to have this system that's scalable, but I also need to do all these different things. And that's something that we were able to do very easily, looking at the current competition that's out there, what those companies have done right over the years and what they've done wrong over the years, and really build this technology that allows us to scale and grow very uniquely. A lot of our competition, they have to do tiering, so there's data workloads and migrations that have to happen in the background. And then we also have, you know, other flash players that are out there, very small capacity, and they do a specific niche type workload, but it's very expensive. So how do we kind of mirror these two things together and create a hybrid type system? We leverage flash for performance. Mute all here again. Sorry about that. We're going to leverage flash for performance while overcoming some of the endurance concerns. We're going to leverage disk for what it's really good at, which is capacity. And we're going to be media agnostic and flexible. So as the market changes, we can evolve. So what does that mean? That means that we use Intel's CPUs. Intel comes up with newer processors every year. We can easily adapt those into our system. And as flash technologies change, we can easily adapt that into our system as well. So one of the things that's really interesting with a Nimble file system is we're not stuck to just using SSD drives. If there's a newer technology that comes out, we can incorporate that into our product very easily. So how do we? And last thing is, how do we leapfrog incumbents on data management, right? And we'll talk about that with InfoSight and some of the other things that we're doing. So CASL, a breakthrough file system here. So traditional storage system uses fixed-based architectures, and this means you know, as the blocks get written into the system, there's no compression. It's a specific block size, and you know, you could run into some issues there. CASL, we use inline compression, so all the data that comes into our system is compressed, and we actually align the blocks to the application that you're going to be putting on the volume or the LUN. So what does that mean? So that means VMware writes in 4K blocks, SQL writes in 8K blocks. So when you create a volume or a LUN on a Nimble system, we're actually going to say, I want to run this application on this volume, and we'll align to that block size of the specific application. So that also comes into play with snapshots and replication. So when we do those snapshots and we do that replication, it's on the same block size that's occurring on that volume. So this allows us to use 30 to 70% less disk space and flash resources. Right? So typically in a VMware environment, we're seeing about 1.5x to 1.8x of compression in those types of environments. Microsoft workloads, Oracle databases, we see upwards of 2x compression on those type of applications. So random writes need a flash tier on traditional base storage systems. So you'll see a lot of these existing storage architectures that are out there creating flash tiers or some kind of other accelerated mechanism for performance. We actually don't have to do that. We inline serialize and write all the incoming I/O sequentially. So as the data comes into our system, we take that data and we package it in this container. It's always sequentialized, and we write that down to low-cost hard drives, SAS drives, and we can deliver SSD-like performance by utilizing the CPU that's in the system. And I'll talk a little bit more in depth about that as well. Fast reads by migrating between tiers, waste flash in a traditional system. So a traditional storage system has some kind of tiering where data has to be moved from the fast tier to the slower tier, disk, or back and forth. Application performance can suffer in those types of scenarios. Nimble uses a dynamic caching. Basically what this means is we can adjust to the workload that's occurring on the system at any given time. So as your applications are requesting more performance, you have more reads coming out of your system, we're able to take those blocks of data and dynamically put those into the cache to accelerate those applications. So we use less capacity there, and we're able to use lower cost drives to accelerate those reads. We shoot to have about a 90 to 95% cache to hit ratio in those types of workloads. Other traditional storage systems, they use copy-based snapshots. They waste capacity, performance degrades over time. So a copy-based snapshot typically can be pretty heavy. On a Nimble system, we use pointer-based snapshots. So everything, it's a redirect on write system. We're only referencing the change blocks or the change pointers that have happened. So what this results in is very small replication, very small snapshots, and instant recoverability and rapid backups. Traditional file systems, they scale up or they have limited scale out. Typically, there's some kind of cycle where every 3 to 5 years you have to go in and buy a whole new product line and do a data migration. With the Nimble, we can scale to fit, we can scale up, we can scale deep, we can scale out based on what the customer workload is. So it really gives us that non-disruptive scaling architecture. Customers can go from a 200 series, an older 200 series product to one of our new 300 or 500 series product seamlessly. And we can handle all the data migration on the back end without any applications going offline. So some really cool things that we can do there as well. So to kind of wrap it up, CASL is fundamentally a CPU-driven architecture. So again, the differences between our product lines from a performance perspective is just the amount of CPU memory we have in those systems. We're able to achieve double the write IOPS of an MLC drive with just a single disk, and there's no write performance bottlenecks as you would with other bolt-on type technologies. So if we look at the bar graph over here, a typical 7,200 RPM spinning disk drive will do about 80 IOPS of performance generally. An SSD drive, typical MLC drive, will do about 5,000 IOPS of performance. And you can see over here, as our products scale here, a 200 series, a 400 series, and a 700 series, we can do way more IOPS than a typical spinning disk based on the CASL architecture using that CPU and memory-based architecture. So how are they different? Let's recap. We have all the same features that you would expect in any storage system today. High availability, snapshots, replication, VMware integration and API support, SRM support, Microsoft Exchange, SQL. We have array phone homes, compression. We also have a lot of reference architectures and best practices out there. So really what makes us different? So CASL is a new file system designed for disk and flash. We can scale based on the latest and greatest technologies that become available to us. Again, performance is based on CPU, not spindles. This is a big takeaway here. A traditional storage system is based on spindles, how many disks can you put in that system. That's not the case with Nimble. It really is how much CPU and how much memory to drive the performance. Real-time SSD caching, so we can dynamically populate those SSD drives to serve the random reads out of the system and not have to do any large data migrations behind the scene. We're a variable block-based file system, so we align our blocks to the application that's being stored on the volume. Integrated backup and retention capabilities. Again, we could have a whole separate topic discussion on the backup and retention capabilities of a Nimble. So I would reach out to Terkai or your local Nimble team, and feel free to ask some additional questions around that. InfoSight, the cloud monitoring and the storage analytics, it's huge for our customers. Again, no cost for this. Allows customers to see when they're going to run out of capacity or when they're going to run out of performance, and also gives them some really deep insights to what's going on inside their storage environment today. Non-disruptive scaling, we can scale all different ways, so we talked about those. It gives the customers very dynamic ways to grow that environment. And then data reduction does not add overhead or slow down the system, so compression for us actually accelerates the system. The more that we can compress that data, the faster and the more blocks we can write down to disk at any given time. So, positioned to lead the storage flash era today. We feel that we're ahead of the game in a lot of different ways. Our technology is a little bit different than what's going on out there in the industry, so we are positioning ourselves as a flash storage player, market leader today. So we'll dive into CASL just a little bit deeper here. I'm going to go ahead and build this slide out. So typically, write tiers are expensive. There's a high endurance to flash to absorb some of those random writes in a traditional architecture. There's a rate applied to those SSD drives in a traditional architecture. There's some kind of migration that requires performance degradation when we're moving data between different tiers in a traditional storage architecture. And we've kind of taken a different approach here. And what we do is we serialize, compress all the data, and we write it down to these low-cost drives sequentially. So essentially, a Nimble array can take anywhere between 500 to 3,000 blocks of I/O performance and package it in a 4.5 meg container, and then we divide that by the number of drives in the system and write it down as one IOP per drive. So we can essentially consolidate IOPS in a way that we're taking 500 to 2,000 IOPS, compress that down into just 12 IOPS as we write it down to disk. So that's how we're able to achieve some of these IOP numbers we get. So as we're writing the data into the spinning low-cost hard drives, we're also looking for data that has been read out of the system or that we think is going to be read out of the system, and we'll place those blocks in the SSD cache. So that way, when applications are requesting random reads, we can populate that request right from the SSD drive. That gives us our performance there. So Flash as a read cache accelerates reads at a very low cost. There's no compression. There's no rate penalties. We're able to use MLC Flash for that. So one of the cool things is the authoritative copy of the data always lives on the spinning disk, allowing us to do those SSD upgrades hot and on the fly. So if you have, let's say, 320 gig of cache in your system, and you say, I need some more cache based on what analytics or what InfoSight is telling us from an analytical perspective, we can buy a larger cache upgrade and just swap out those SSD drives on the fly, and they'll be repopulated with hot data. So we're able to substantially get more performance and capacity. So we're utilizing SAS drives, we're utilizing MLC SSD drives. The inline compression compresses all that data. So we're able to adopt those workloads a lot easier. So we talked about the scale to fit here. There's a little bit different view of it. Over on the left-hand side, what we have what we call a scale up, and this is our performance scaling. So this is going from a 300 series to a 500 series by doing a controller upgrade or adding more cache into the system. We have scale out where we can create that 4-node cluster and create those large environments. And then along the bottom, we have our capacity scaling. This just allows us to scale and add more capacity into the system. Traditional backup environments today, typically we see customers that have all sorts of things, but typically they'll do some kind of disk-to-disk and then maybe some tape, and as well as replication using a lot of different applications. It might be, Veeam or Zerto or some other type of application there, or Symantec. And it really becomes a pretty cumbersome environment. You see customers backing up the disk and they're replicating that to another disk, and then they're going off to tape. And it really becomes a pretty complex environment just from a backup perspective. So we wanted to simplify that. We have a lot of customers that have just removed all that complication from their environment. They'll put in a pair of Nimble arrays, and they'll utilize our snapshots and replication to resolve some of the challenges they have with their current backup infrastructures. So what does this allow us to do? There's no backup windows. Everything is instant. We can recover locally. We also have a copy of the data on the DR side. So it becomes very cost-effective when you look at putting multiple Nimble arrays in versus paying for all the software, the licensing, and the tapes from a traditional backup protection scheme. So instantaneous zero-copy clones for test and dev instances. We have a lot of customers that utilize this today. So you can take let's say you have a SQL database that's a production database. You can snapshot that volume, non-impactful to the application, and you can give that snapshot. You can clone that into a zero-copy clone, which means it uses no additional space unless data is written to it, and you can give that to your QA or your test dev, and they can have an instant copy of that production database to do some workloads on without actually impacting the production workload. So there's lots of different use cases there. It's a very unique, very interesting feature that a lot of customers take advantage of, specifically around DR testing and application development. So proactive wellness, we've talked a little bit about this throughout the presentation. So we have predictive analytics to anticipate issues that are going to happen in the environment. So about back up here, one of the interesting things here is we don't have a tiered-based support system. All of our support engineers are level 3 support engineers. Utilizing our proactive analytics and our auto supports, we've been able to reduce and eliminate the requirement for a tier 1, tier 2 type support. A lot of that is automated. So when you do call into Nimble support, you're getting a level 3 engineer, that person has the auto supports from your system, and they can begin helping and troubleshooting right away without doing any kind of core dumps or data dumps and having to provide those to us. We have all that data. Triple parity RAID, high performance protection there, so we can lose multiple drives without impacting the system. Fully redundant design with fast failover. So again, we're an active passive standby controller system that's seamless to the applications if there was some kind of hardware component failure there. And then non-disruptive hardware and software upgrades. This one is a huge one. I get asked this question a lot. Is it safe to upgrade my firmware? Am I going to run into any issues? Nimble has done a very good job at building in protection around firmware upgrades and checks and balances in the system. I would actually encourage everyone to go out to nimblestorage.com and go to our blog. Our VP of support, Rod Bagg, did an interesting post about 2 weeks ago around when customers actually apply firmware to their systems. And because of the auto supports, we're able to see what times of day that these firmware upgrades were done. And 64% of our customers upgraded to our latest 2.1 code release between the hours of 8 a.m. and 5 p.m. Monday through Friday. So again, go check out that blog post. It was pretty interesting to see when customers are actually applying their firmware upgrades on the system. So 90% of our support cases are auto-detected. This means that our auto support does a lot of those level 1 and level 2 type support tickets. Because of that, we're able to provide the customer an email saying X, Y, and Z has occurred on your system, and here's the 3 steps to resolve that on your system. If you have any further questions, just call into Nimble. So 90% of our support cases are auto-detected. We have 5 nines proven uptime across our install base. And we also, 80% of our support cases are automatically resolved based on the auto support system. So only 20% of the time are our customers having to call into our support center. So in a connected world, why can't other vendors proactively monitor their customer systems? That's a great question. It all comes back to the architecture and design of the system. So if you build something from the ground up and you're able to build in this functionality it's very easy to scale it. It's very hard to go back and retrofit something that's been existing for a long time. So this is our way of showing the industry that InfoSight is a powerful tool, and providing this to our customers gives them a lot of benefit in what's going on into their environment, not only from auto supports, but also from a deep down, how many IOPS, what is my latency numbers, when am I going to need to buy more storage. That's all provided right in InfoSight. So I would encourage you to reach out to Terkai or your local account team and schedule a demo if you want to see what that looks like. So the cloud-based management here, so we have about 30 million touch points that come in every day into our data center from all the arrays that are around the world. We're able to analyze that. We're able to automate a lot of those support tasks, provide customers with interesting analytics around what's going on in their environment to help them improve and fine-tune things. We're also able to offer storage as a service. So we have a storage on demand option as well, utilizing InfoSight. And then we also have a great community learning portal called Nimble Connect, which is an online forum-based community around Nimble. So there's a lot of interesting scripts and cool conversations going on there. So definitely check that out as well. So that's it from the presentation.
I hope all of our attendees found it as informative and valuable as we did here at Terkai. Yeah, great job. We look forward to talking with you again soon. Have a great day.
Thanks, Jake. Thanks, everyone. Have a great day.
Thank you.